learners. This is Education Online program, and in our today teaching we are going to have chemistry as a subject, and in front of you is teacher Lily. Our topic today is relative atomic mass and relative molecular mass. So these two terms, they are different, and we need to know that the relative atomic mass, this is dealing with atoms, and the relative molecular mass is dealing with the molecules. Or in the middle we shall say that it is, instead of relative molecular mass, we are going to say that it is a relative formula mass, so that it incorporates the ionic and the molecular compounds. So what is this relative atomic mass? As we start with, we are going to start with this relative atomic mass, and it is abbreviated by RAM. So relative atomic mass, here we say that it is dealing with the atoms, and if we say that it is a relative atomic mass, how does it come about? We are going to say that this is representing actually the mass of the elements. For example, you can have carbon. Let me say carbon 12. We say that the relative atomic mass, here we shall say the relative atomic mass for this element is 12. This is representing the atomic number. So the relative atomic mass here is 12. So we are comparing this atomic. We are saying that it's relative. It should be relative to the standard set, which is a carbon isotope 12. So carbon isotope 12 has been set as the measurements for the atoms or the elements, so that they shall have the relative atomic. When we are relating it to carbon 12, which means that carbon with the mass number 12, so we say that it is the relative atomic mass of carbon. So we are relating this to carbon 12. So it is easier to determine the relative masses of the atom in comparison with each other. So when we compare relative atomic mass, here when we are talking with relative atomic mass, it is easier for us to determine when we are comparing atoms with other atoms. So if we say that carbon 12, and we have to compare it to magnesium, what is the mass of magnesium? We say it is 24. So when we relate it to carbon 12, then we shall say that this is the relative atomic mass of magnesium, the relative atomic mass of sulfur, relative atomic mass of oxygen. So all the elements or all the atoms has the relative atomic mass. So their masses are related to carbon, as we said that carbon is taken as the reference element. Which carbon is it? As carbon 12. So all atomic masses are compared to 1/12 of carbon. So we said, if we said 1/12, so we said 1/12 of carbon. So all the elements are compared to 1/12 of carbon 12, which is having a mass of 12. So if we said carbon 12, then we shall say that this is the mass of carbon 12, and any unit or any compound is compared, any element or atoms is compared to the mass of carbon 12. So we say that 1/12 of carbon, which is the reference element. So in this case, if you said 1/12, it means it is showing how heavier or how lighter that element compared to or relative to carbon 12. So it is actually telling us that how heavier or how lighter the element or the atom compared to carbon 12. So it means here, if you have hydrogen, hydrogen with atomic number 1, so it means its mass is 1. So when we compare it to carbon 12, so we shall say that it is 1 over 12. So it is lighter than carbon 12. So if you say magnesium, which is having atomic number, mass number 24, then we shall say that it is 24 over 12. So when we compare it to carbon 12, we may see that magnesium is heavier than carbon. So if you take sodium with atomic number 20, mass number 23, so we shall say that it is 23 over 12. So we compare it to carbon 12. So we say that magnesium and sodium, they are heavier than carbon 12. And hydrogen is lighter than carbon 12. We can have also another element like lithium. So lithium here with the atomic mass number 6, so we shall say that it is 6 over 12, so it is lighter than carbon. So here we are relating these atomic mass numbers to that of carbon, and we say that this is the relative atomic mass of carbon, relative atomic mass of hydrogen, relative atomic mass of magnesium, relative atomic mass of sodium, and that of nitrogen, which is 6. So here if we say that we are knowing or we are getting the relative atomic mass, we are measuring how many times that element or that atom compared to carbon 12. This is exactly what we have already seen here. So magnesium is heavier, lithium is lighter than carbon, and hydrogen is lighter than carbon, while sodium is heavier than carbon. So you can have copper. The relative atomic mass of copper here is represented by 63. So here the mass number is 63. It means the relative atomic mass will be equals to 63. So here we are comparing it to carbon. It means here we are seeing that copper is much heavier than carbon. So in this case, we shall say that here copper is much heavier than carbon by relating it to the atoms or to the mass number of carbon 12. So elements have the same number of particles in one molecule but different relative atomic mass. So the same elements usually have the same number of particles but different atomic masses. So here we say that copper and magnesium plus sodium, they are heavier atoms compared to carbon. So we shall say that here we are relating these elements atomic masses, the masses of this element compared to the one of carbon, which we refer to as the reference elements. So here we shall say that nitrogen, for example, is 14 or having atomic mass 14, though the same number of atoms are the same number of particles. So we shall say that all the elements, they have the same number of particles, which we refer to as the Avogadro's constant. The same number of particles, all elements have the same number of particles, but they have different masses. And here the number of particles is the Avogadro's constant, which is 6.022 times 10 to power 23. And here we can say that the mass of these elements are different, but their masses differs. But the mass numbers differs, are different. So we said all elements or all atoms have the same number of particles, which is 6.22 times 10 to power 23, but they have difference in the mass number. So the mass number are different. So it means here carbon has the number of particles equals to, carbon has the number of particles equals to 6.022 times 10 to power 23, but the mass number for carbon 12 is, so the mass is 12 grams. So the mass number is 12 grams. So here we have magnesium has the same number, which is the same number of particles, 6.022 times 10 to power 23, but the mass number of magnesium is 24 grams. So we shall say that the mass number of all the atoms or elements are different, but their number of particles are the same. So we shall say that all the masses are different. So that is why, although we relate it to carbon, we say that carbon is just the reference number, or it has been taken as the reference number for comparing or relating the atoms or the mass numbers of each element or each atom to the one of carbon, so that we see whether which element is heavier than carbon. So here, for example, you are given that carbon. Why do we choose it as the reference element? Here we say that carbon has weight to have 12 units. So here we say 12 units, or here we refer to this one as the mass of carbon, but we take it as 12. It means if it is 12, it has 12 parts or 12 units to form 12 mass number of carbon. So if we take one out, it means we shall be remaining with 11 units of carbon. If we take 2 out, then we shall be remaining with 10 units of, it means there are 10 parts of carbon units remaining in the mass of carbon. If we say that hydrogen, so if you say that 1 unit has been taken out, we can say, refer to this one as one atomic mass unit has been removed from the reference value here of carbon, which is, we can refer to it, or we can put it as the atomic mass unit 1. So here we shall say, when we are writing the relative atomic mass, we shall say that 12 AMU, we are referring to atomic mass unit, or we can say a unified mass, or we can represent it by only capital U. So we shall have this is referred to as the unit for measurements of the relative atomic mass. So 12 of carbon, we shall say 12 AMU, or we can say 24 AMU, which is referring to the relative atomic mass of each element. So here when we say 1 AMU, we are saying 1 out of 12 parts of carbon, 1 is taken out. So 1 unit has been taken out, and we refer to 1 unit of this element or atom to be AMU, and this is the unit for representing the relative atomic mass. So if you said mass of oxygen, If we said mass of oxygen atom, mass of oxygen atom, so the mass of oxygen atom, as we know from our previous lessons, we say that is equals to 16 units of carbon, or we can say 16 AMU, which is the atomic mass unit. So if we said 16 units of carbon, which means that we are representing the atomic mass of oxygen, or relative atomic mass of oxygen. Or if we said 16 AMU, we are referring to the same units of carbon, which is 16 for oxygen. So when we go to the second part, which is the relative molecular mass. So here the relative molecular mass is not so different, that doesn't have so much difference with the relative atomic mass. It's only here that we are dealing with the molecules, or we are dealing with ionic compounds. So you can say relative molecular mass, which is represented by Rm. So here we say relative molecular mass, or we can say Rmm. So here it is the abbreviation for the relative molecular mass. So when we say relative molecular mass, we remember that one atoms combines and they form molecules. So you can have you can have one or two atoms combining together, or even three or more combining together to form what? To form compounds or molecules. So we say this is whereby we say the relative molecular mass. It means when these elements combine together, or these atoms combine together, then we shall say that this is a molecule of carbon dioxide, a molecule of carbon monoxide, molecule of water, molecules of copper sulfate. So the molecular mass of a compound is the sum of all the atomic mass of each atom in the formula. So the relative molecular mass here, we are referring to the number or the atomic masses of the elements or the atoms that form the compound. So we have to get the sum of the atoms present in the compound, or in this ionic compound, or the molecules, then we add them together to give us the relative molecular mass. So in this case we call it as the relative molecular mass. So here we say that it is referring to the sum of atoms in a compound or molecules. In a compound or molecules. So here when we say the sum of atoms, it means any compound is formed from either 2, 3 or 4 atoms, or any molecule is formed from either 2, 3 or 4 atoms. So we need to sum up the relative atomic mass of those compounds, of those atoms, then we get the relative molecular mass of the compound. Can be either the ionic compound or the molecular compounds. So we said here that this is relative molecular mass when we are talking of only molecules. But here, because there are other compounds which are ionic, so we say that these compounds, this formula is not okay with it, but we can say it is the relative formula mass. So when we are talking of molecules, or we are talking of ions, we say that this is a relative formula mass instead of relative molecular mass. So instead of relative molecular mass, we say is relative relative formula mass. So here we say it's relative formula mass because, so relative formula mass, we are saying that it is should be relative formula mass because here all the compounds or most of the compounds are either molecules or they can be in ionic form. So we have ionic compound or molecular compounds. So ionic compound or molecular compound, that is why we refer to this term as the relative formula mass instead of relative molecular mass. So if we are talking of molecules, then we say relative molecular mass. But if we are talking of what either compound, ionic compound or molecular compound, then we refer to it as relative formula mass. So here we said, how do we get this relative formula mass or this relative molecular mass? As we say, that is the mass of one molecule of an element or a compound. So we have already talked about that one. So we shall say, how do we get this relative formula mass or relative molecular mass? So we shall have an example to represent a compound with the such kind of terms. So the relative molecular mass, in this case we have a molecular compound. So we shall have this compound here, these compounds, the molecules are having, we shall have, it will have the same number of moles, the same number of particles, but they differ only in the relative molecular mass number. So for example, you have hydrogen gas or hydrogen molecule. Here it has the same number of moles. So in one mole of it will contain, one mole of this molecule contains Avogadro's constant, which is 6.00022 times 10 to power 23. So one mole of hydrogen gas or hydrogen molecule contains this number of particle, which is 6.022 times 10 to power 23. So here what will be the relative formula mass for this compound? So we shall say, because there are two atoms of hydrogen here, then we shall have to add what? The relative atomic mass of hydrogen. Here the relative atomic mass of hydrogen will be 1, and if you add 1 to 1, then we shall have 2. So the relative formula mass here, relative molecular mass, will be equals to 2. So because we are adding 1 atomic mass number plus 1, then will give us 2. So one relative atomic mass of hydrogen plus another relative atomic mass of hydrogen, then will give us this relative formula mass or relative molecular mass for hydrogen gas. So if you are given carbon dioxide, so here carbon dioxide is a molecule or a compound formed from two types of atoms. Here we have carbon and also we have oxygen. So how many atoms of oxygen do we have there? We have 2 atoms of oxygen. So in this case, we shall sum up the relative atomic mass for each atom to give us the relative formula mass or the relative molecular mass of carbon dioxide. So we shall say that here we are representing the number of moles here, number of moles, and we have particles, number of particles, the number of particles, and here we have the relative formula mass. So we shall say that these compounds here, or these molecules, they have the same number of moles. Here we have 1 mole of this compound. Then it will contain 6.022 times 10 to power 23 number of particles. Then the relative formula mass will be, we are adding relative atomic mass of carbon plus the one of the 2 atoms of oxygen. So in this case, we shall have 44. So how does this 44 come about? We shall say 12 plus 16 multiplied by 2. Then we shall have 44, which is the relative formula mass for this compound. Again, when you have nitrogen dioxide, we have this molecule is formed from 2 atoms, also nitrogen and oxygen. So we do the same by adding to get the molecules. Here we have 1 molecule, the same number of particles, but they differ in the relative formula mass. So we shall have 14 plus 16 multiplied by 2. Then we shall have the mass number, or the relative formula mass, to be equals to 46. So they have here we shall say that all these molecules, they have the same number of particles, and in 1 mole, then the relative molecular mass is the one that differ, or their masses differs in this case. So we have seen that how we calculate the relative formula mass or relative molecular mass for both ionic or molecular compounds. So here, when you're provided with the relative when you're asked to calculate the relative molecular mass or relative formula mass, then you have to do the same procedure as we did here. 14, for example, for nitrogen dioxide, we have 14, which is the relative atomic mass of nitrogen, plus oxygen 2, we have to multiply by 2 the relative atomic mass of oxygen, then we multiply by 2 because there are 2 atoms of oxygen. So we sum those relative atomic mass of the atom that constitute nitrogen dioxide, then will give us the relative formula mass. So this is the difference between the relative atomic mass, as we said it is for atoms, the first one, and the second one is for the molecules or compounds, either ionic or molecular compounds. So with this, we have come to the end of this lesson. So thank you very much for listening. I'm teacher Lily.